Hey, Math 1, this is Mr. Roberts at Shasta High School. On Monday of September 16th, we had some guest presentations in our class. And one of the problems they talked about was this problem that involved getting a job at Cinemark Theater. And I want to describe that situation and talk about the 5 different ways that we can represent a problem situation. And I want to show you how to use some technology to generate information for all 5 of those. Specifically, we're going to be looking at using the TI calculators that we have in the classroom and that quite a few of you have outside of the classroom for looking at problem-solving situations. So the deal with this problem was that you are fortunate enough to have been offered a job at Cinemark, Movies 14, but you've been told, oh, but you've got to buy this uniform, right? And in fact, the uniform, if you recall, costs $35. So up front, you have to pay $35 for the uniform that you're going to wear while you're at work. And the job right now is they're offering to pay you $8.25 per hour. So what we talked about in class was, modeling the amount of money that you make as a function of the number of hours that you work at the theater. Because this uniform is something that you have to buy up front, and actually they volunteer to take it out of your first paycheck. At first, technically, you actually owe them money. You owe them $35. It took a while, but I'm very happy to say that almost all of you kind of came to an agreement today that a function that modeled this situation looks like, again, this is a function that gives me the amount of money I earn. Just considering these 2 factors, I earn $8.25 per hour, and that was the constant rate at which my money is accumulating on my paycheck, and that's going to be multiplied by X. But I have to subtract from that this $35 that I have to pay for the uniform. So I look at this, I've got here a nice function that models the situation. If I work exactly 0 hours, I will owe $35. In fact, I'll put that down over here. The other way that we have of modeling our function is using a table. So I'm going to model this function also using this table. So here's some x values, and then here's some f of x, some output values, right? So in this situation, time is my independent variable. It's how many hours I work, and the dependent variable is the amount of money that I earn. If I work 0 hours, I actually owe $35, so it's negative 35. And another number that we came up with that was kind of nice is if I multiply $8.25 times 4, 4 times 8 is 32, but I have to add one more dollar because there's 4 quarters there as well, so that ends up being $33. So when I work 4 hours, 8.25 times x is $33 minus 35 gives me negative $2. So even after working a full 4 hours on the job, I still haven't paid for that uniform fully. Another way that we can model the situation, of course, is a graph. On the graph, we can let our x-axis represent the number of hours worked. This would be my hours worked. And the y-axis would represent the number of dollars I've earned. And if you think about this initially, right, we have a very, very we have a negative value at first, right? When we plug in x as 0, we are way down here at some number like negative $35, right? And at a certain point, like when x equals around 4, like we're still in the negatives. We're still at negative 2, and at some point we burst past that, right? Now this is just a kind of a primitive sketch, but let's fill in some of the information that we know, right? For example, we know if x is 35, or I'm sorry, when x is 0, y is negative 35. And we also know that when x is around here at 4, y is still at negative 2. So this just a really primitive sketch. Another way that we can, help kind of get a grasp on it is consider just a particular ordered pair. And one of the ordered pairs we'll consider is this particular one. This is something that the presenters on Monday thought it would be a good idea for us to look at. So if I'm pulling out a particular ordered pair from this data, I could say, well, I know that if I work 4 hours, that I still owe $2 for the uniform, right? So at 4 hours, I still haven't made any money. I still owe $2. So these are the different ways that we can visualize a situation. And at this point, I'm going to shift and I'm going to bring in our calculator because I really want us to kind of get proficient at using the calculator to collect data for these, or to model or to show different aspects of this particular problem-solving situation. So here's the calculator. This is a lot like the ones that we use in the classroom, except it's a virtual calculator. And I don't think you can see. Oh, that's glitchy. You can't quite see all the buttons. Some of them are below the screen here, but I'll be tapping them as necessary. So let me turn it on. And I'm going to go ahead and enter this, first of all, the function, right? So whenever I want to enter a function in my calculator, I'm going to be using the button up here, the upper left button that says y equals. So when I tap that, this calculator is completely cleared out. Everything's been reset, so there's nothing here. If I had a particular function, let's say I was looking at, I turned this on and it said 5x for this, y1 equals 5x. For me to clear this out, I would just move my cursor to that particular function and then press the clear button, and it'll remove it. So let's look at this function, right? I've got $8.25, so 8.25, and I'm going to be multiplying that by x. Right here is the button that we use when we want to access variables. And depending on the context of a problem, our calculator will automatically shift to using t, theta, or n. In this case, it's going to give us x, so 8.25x, and then I need to subtract $35, so minus $35. At this point, I'm ready to, I can graph it, and I can also generate a table of values. Let's look at the table of values first. And there's a couple ways we can do this. Right here, there's a button that says Window, and right above that it says Table Set. It's kind of hard to see on screen, but if you have an actual calculator in front of you, you can see this. If I press Second and then Table Set, what it asks me is a couple simple questions here, and we're going to play with many of these features. The first thing it asks me is, where do you want me to start x values at? And right now this is set up so that x's are going to start at 0. And the next line says, and how do you want to increase those x values? And it's set up right now to increase those values by 1. So I'm going to be generating a table of values that would include 0, 1, 2, 3, 4, etc. And I'm telling it that the independent variables, go ahead and do this automatically based on this starting in this increment. And then also go in and calculate the dependent variable automatically. So with this set up like this, I can go ahead and display my table. The table is displayed by clicking, again, Second, and then right above Graph it says Table. So I'm going to click Table. And you can see I have all the values here, right? At 0, I am at negative $35. After working 1 hour, I've increased this by $8.25, and now I'm at negative $26.75. At a certain point, this one value that we saw, which was 4, right, I'm at negative $2. And there's a couple more here, at 5 hours, I will have, whoa, I didn't know that would disappear on me. At 5 hours, I think I can make this calculator always stay on top. Let me see if I can turn that on. View, File. So I made the adjustment now so that the calculator will always stay up on top. So I was saying at $5, it looks like I've earned $6.25. At 6 hours, it's $14.50. And there's a lot more values here that I could choose to write down and investigate. And in fact, if I bring my cursor over, I can jump down and I can see tons of different values. Now I want to show you a different way that you can manipulate the table. Right now, it's automatically generating the list of input values based on this. Oh, I can go down and look at negative values as well. It's generating this list automatically for me. Now I'm going to come in and I want to tweak this a little bit. I want it to stop what it's doing. Stop. So the other way that I can approach the table, and again, I get at the table setup by hitting second and table set, TBL set, is instead of doing this automatically, starting at 0 and increasing by 1, I can simply switch it to the set where it says ask. So when I'm in this mode, if I go back to my table now, so I'm going to press second, second, and then back to table. When I'm in this ask mode, what it does is it says, hey, you give me an X, and I'll calculate Y for you. So for example, I say, hey, I worked 0 hours, and I press enter, it'll say you owe $35. If I say I've worked 1 hour and press enter, it'll say you've worked you owe $26.75. And when I could jump ahead and say, hey, what about when I work 6 hours? It'll say you earn $14.50. So any number of hours I wish I can just enter and look at. So, for example, let's say that I want to say about how many hours do I have to work to earn $60. It's really pretty quick for me to kind of jump around here. 11 is 55, 12 is 64. So if I'm trying to earn $60, I need to work a little bit more than 11 hours. In fact, I could say this. I could say, how many hours do I need to work if I want to earn at least $60? Well, if I want to earn at least $60, and I'm talking about even number of hours, I need to work at least 12 hours. And if I can't have half-hour shifts, in order for me to earn at least $60, I would have to work at least 12 hours. And certainly if I worked 13 hours or 15 hours or 20 hours, certainly it would be true that I would be earning at least 64. In fact, I would be earning quite a bit more at that point. Anyway, so that's one way that we can go ahead and set up our table so that we can enter a value. Like if I work 50 hours, it'll say, oh, you should have $377.50 for the life of the job. Hey, I got bad news, though. Of course, I'm not talking about SSI. I'm not talking about any other taxes that may come out of this check. And those of you, your parents will tell you it's just like it's not going to be quite the number of hours times the dollars per hour because something's going to happen in there. But for this overly simplified situation, and is it common for people to get charged for uniforms or clothes? Yeah, it is. And I think if you're itemizing, maybe you can deduct that at tax time. I don't know. I'm not a tax attorney or a person who does tax preparation. Okay, let's take a look now at the graph. We've looked at the function and the table. Let's look at the graph of this function. So I'm just going to, without even thinking about it, you can see I've already got the function in here. It's y equals $8.25 times x, the number of hours, minus 35. If I just press graph, I'll sit and let it run for a while, and you can see it did actually show something. That doesn't look quite like the graph I've sketched over here, but I do see kind of this. It's increasing over time, and it definitely starts out in the negative zone. I want to talk about, and I don't know that our book talks about this, but I want to talk about setting up a window that makes sense for a problem. If I'm looking at this problem, it certainly doesn't make sense for me to talk about working negative hours. In fact, if I look at this, the number of hours I work, it would start at 0 hours, and it could go up to some number of hours x. So if I'm looking at this is a window into my graph world, right? And in fact, I think I can grab that and put it right here. If I'm looking at this window into the graph, right? Sorry about that. That's a silly mistake. If I'm looking at a window into this graph, right, I certainly can see that the graph is starting somewhere, right? I think this is actually starting at negative 10 and going to positive 10 for x. And it's doing the same thing for y. It's starting at negative 10 and going up to positive 10 for y. So this is one window that I have at looking at the graph. I can certainly change this window quite a bit to give me a better view of perhaps what's going on. So let's do that. We're going to manipulate this, and I hope you kind of see what's happening here. The button I'm going to use is the one right under my graph window that says window, and I'm going to touch it. And once I'm in this view, it's going to ask me, first of all, what's the minimum x value and what's the maximum x value that you want. So these numbers, they turn out that they're literally talking about, what if I was to look at these, that the minimum x values are like the things that are like down to here, like what's the smallest x we want to see, and then the max is what's the largest x that we need to see. For min and max y, what's the smallest y value we want to see? And I think it would be nice to see 35. And then the max we want to see, that's like a certain number of dollars. Um, Let me get all of that nonsense off the screen and have us go ahead and change those things. So let's say that our y value, our x values are going to start at 0, because we're going to begin working 0 hours. We're certainly not going to work negative hours. And let's go up to, I don't know, we'll say we work a total of 15 hours. Well, actually, on this window, we'll say that we work up to 20. This is arbitrary, but I know the biggest number of hours I'm going to be able to see on here is 20 hours. For the money, I know that I start out at negative $35. Now, this is a bit tricky, and I want to make sure I point this out to you. There's two buttons that kind of look like negative on your calculator, right? One of them is the minus symbol right here, and this is the button I use when I have a quantity I want to subtract another quantity from it. So like, 10 minus 3. The other button that I have is just slightly off your screen, and I can't make you see this. Oh, that's terrible. It's hmm. It's just below the screen, and what it has is this little thing that looks like it's a negative in parentheses, and it's on the button that says ANS. That's the button that we want to use whenever we want a negative number. So unfortunately, I can't show you that, but I'm going to press it, and notice I didn't press minus and then 35. So that's negative 35, and I'm going to be I'm going to go up to a maximum dollar value of 200 in this window. So I'm going to go ahead and hit graph now that I've changed my window, and I want you to see how this has changed the view that I have. On this view now, you can see that we're starting off with negative 35 is right about down here, right? And the minimum hours I have is 0 hours, and it goes up to 20 hours. And I'm not exactly sure where this goes off. To know what this is exactly, I'd have to figure out how much money I would work or earn if I earned $20. And actually, that's not difficult to do. All I would have to do is come back to my table, for example. So just not second table set, but second table. And I could just come to my table and say, hey, if I worked for 20 hours, it would tell me that's $130. So right up here, right where this is just starting to leave the screen, that's $130. Remember what my axes are. This is dollars, and along here I've got hours worked, right? So hours worked are in time worked in hours. So this is really great. I can totally look at it and answer a lot of questions using this tool. And in fact, I want to clear the screen up and kind of show you some of the questions I could answer. Let me go ahead and erase this also. And I think I'm going to get rid of this line. Let's leave that down there, and I'll bring this back up. So let's come back in and look at our graph. And we know what. I'm just going to put this here actually over the graph area that we have, kind of. I know that this line, right, with this constant rate of change, this is modeling the function $8.25 per hour minus $35 for the uniform. And it's pretty straightforward for me to answer questions like this. Like if I want to know how much money do I earn if I work 3 hours, right? So in other words, what I'm asked to find here is what is the function when my input is 3 hours. Well, to get that, it is 3 times 825, and then subtract 35 from that. Of course, we can quickly go to our table, and we can look at that and say, oh, if I work 3 hours, it's going to be -$10, -$10.25. I could come in and I could say, by the way, that is an ordered pair, right? When x is 3, I get -10.25. I could answer a question like, hey, if I work 10 hours, how much money would I get? And I could see that that's lines actually right here, right? When I work 10 hours, I'm going to get $47.50. So those are pretty easy questions to answer. A little bit more challenging to answer would be, what if I want to know, let's say that this line right here, I think I'm going to move this line up a bit. Let's say that this line here represents the value of $150, right? So it's $150. And my question is, how long do I have to work in order to earn $150? How many hours is that? Um, Now I could come over here to my table and I can start, guessing like, well, what if I work 100 hours? That's too big. What if I work 30 hours? That's 212. Let me cut that in half. I don't know. What if I work 15 hours? That's 88. Any more than that? 17 hours. It's 105. Okay, what if I work 16 hours? So I can see it's in between 16 and 17 hours. So it's kind of a nice way to what I'm doing here is I'm using the table to find an approximate answer about when that's going to happen. Um, I can certainly do what we talked about earlier in the class. I can say if I want to know how many hours it's going to take for me to earn exactly, um, what did I say, $150, I could come over here and I could say, well, let's look at the function that's modeling this situation, right? F of x is the output value, and I could say, what if my output value is $150? And I want to know when x produces that 150. So I could say, hey, look, the dollars earned equals the dollars earned. Certainly that's true, right? This function is the dollars earned equals the dollars earned. So I could say that equals $8.25 minus 35. And I could solve this pretty straightforward equation by using my properties of equality. I could add 35 to both sides and then divide both sides by $8.25. And that would give me the exact value. In fact, let me do that and write that down. So I'll take $150. Let me quit the graph. $150, and I'm going to add to that $35. And once I've done that, I'm going to take that and divide by 825. And when I do that, I get that it's going to take me 22.42, and you can see the 42 is repeating, right? X equals 22.42 repeated. So about 22 hours, right? I'm going to have to work, well, 22 and a half hours. And I would get up to the desired $150. One of the things I could do with my calculator is I could come in here and I can add another function. Right? I've already got a function that describes my earnings, but let's say that I'd add this constant function, just 150, right? There's no variable in there. There's no change. It's always going to be just $150. Let me try to graph that and see what happens. Now, when I graph that, right, you can see this line going across $150. The problem I have right now is that my window is not quite big enough. Remember, I ended my window at 22, or at 20 hours. So I need to make this window a little bit bigger because what I want to see is where this $150 is crossing my line. So I'm just going to change my window, hit window, and I'm going to make the window so that x's go a little bit bigger. I'm going to make x's go all the way up to 25 hours. And when I graph it now, you can see here's my function, and here's $150. And we can see that, yeah, certainly there's a spot right here where $150 reaches my function. There's a really super easy tool on our calculator that'll allow us to identify that spot exactly. What it is it's on the calc menu. So I'm going to press second and go to calc. And what I'm looking for is the intersection of two lines. I want to know where this line, right, this line right here meets this line. And if I could find where those lines meet, that ordered pair is going to be the number of hours I have to work to produce $150. So I can come down here to the tool that does that is intersect. This is going to tell me where two lines, two curves intersect. I'm going to press enter. And it asks me which two curves do I wish to consider. The first curve is the one that I'm on right here. It's the curve that describes my earnings. So I press enter. The second curve I'm going to use is the $150 curve, right? Which is just a straight horizontal line going across. So I've got those two curves selected, and it says, well, what's a guess? Where do you think a guess is? And you don't have to be real accurate with this. I'm just going to move my cursor a little bit over, so I'm guessing somewhere. That's interesting. This calculator is not working well on screen. So I'm pretty close to it, right? So I'm going to guess in here. Then what you do is after you've decided you've gotten close to where your guess is, just press enter again, and it'll actually zero on that spot. And I want you to look at the significance of this, and I'll write it down as an ordered pair. This is telling me when x is 22.42 repeated, right, 4242, y is going to be $150. So what this does is, there's two ways we can do this now. We can use our calculator and use its ability to find the intersection of lines to come up with the value of, when I work 22.42 hours, I get about $150. And then going the other way, if I work 3 hours, it'll tell me that I earned 10.25 hours. Well, I think that's probably about enough for today. Again, to wrap it up, what we have here is the ability to look at a function, enter the functions in y equal. We can set up a table. We can make it auto, or we can make it ask for values. We can look at the table with second table. Look at it's graph the other curve there. It's always $150. If I enter a value for x, it'll calculate that for me in y1. And we can also look at a graph. We can look at a graph. And if I want, I can calculate some of the intersecting points, like where certain lines will intersect. We are now at 27 minutes. I apologize for the length of this video. This is Mr. Roberts saying goodbye.